Well, I saw this question on YouTube. I found that I have a much better way, much easier way to do it. So this could be written as well in two fractions. Right, the first one is e to the negative x times 1 over x. The second one is to cancel x. You get e to the negative x times log x dx. Well, this is very well. This is a perfect the derivative of product. This is the derivative of e to the negative x and the log x. Now, this derivative times this is this. This derivative times this one is that. So that's easy to do it. So this is e to the negative x times log x plus c, right? Now, this question inspired me have something to do with this kind of integral, e to the x times sine x dx. You must have seen this when you learn the method of by parts, right? Okay, now here, that inspires me that I can do something like that, use the product rule. I let this be I. I create a j, which is e to the x times cosine x dx. Now, then I plus j is equal to e to the x times sine x plus e to the x times cosine x dx, right? Yeah, this is the derivative of a product. This is the derivative of a product, which is e to the x times sine x. This derivative is this times sine plus this derivative is cosine times that. See this? Right? This is equal to e to the x sine x, say plus c, 1. Now then I do no, I minus j. This minus that, right? This is equal to e to the x sine x minus e to the x cosine x. Well, this is also product rule. This is the product of e to the x times cosine x. This derivative is this. This derivative is a negative sign, negative. This derivative times this derivative times this one is a negative, right? This derivative, you see e to the x times this one is negative. Here it's perfect. So this is equal to negative e to the x cosine x plus c2. Now then, we're looking for i's, right? We're looking for I. 2i is equal to I plus j plus I minus j. So this one plus this one is equal to e to the x, common factor, sine x negative cosine x plus c. 3, right? This plus is 3. Then divided by 2. So my I is equal to 1/2 e to the x sine x minus cosine x plus c. Yeah. See, very easy. Very easy using this method. Also, we can find this. Find a j, you know. How to find a j? This minus that. This minus that is divided by 2. You get a j. So I think this is a wonderful method, you know, to do this kind of integral. And then further, we can do this type of integral, e to the 2x sine 3x dx. We can use the same method, you know, to do this type of integral, which is not that easy when you learn the method of by parts, right? You you repeat the couple of times by parts, then you get the result. Now here, well, I think I'm using same method. Let this be I. I created j. J is equal to e to the 2x times cosine 3x dx. Well, I tried to use the same method I did before, right? Yeah. Now, the idea is that I try to get this, right, to the 2x sine 3x. That one requires 2 e to the 2x plus 3 e to the 2x. No, let me repeat again. This requires e to the 2 to e 2 e to the 2x times sine 3x plus 3 e to the 2x times cosine 3x. Correct. Dx. Correct. That is this. And similarly, this one, cosine 3x, requires 2 e to the 2x cosine 3x minus 3 e to the 2x sine 3x, right? Dx. All right. So these one I can work out in the rough paper first. Then I know that this is a 2i. This is 3j. So in other words, 2i plus 3j will be equal to this. Will be equal to integral 2 e to the 2x sine 3x, right? So that is this one, plus 3j, 3 e to the 2x, and cosine 3x dx, right? That is the derivative of the product. This is the derivative of e to the 2x sine 3x, right? That's perfect. I've done before. This one is equal to e to the 2x sine 3x plus c1. Similarly, from this, I know that I need 2j minus 3i. 2j minus 3i. So 2j minus 3i is equal to this. 2j is equal to 2j, 2, that's 2j, minus 3i, 3i sine 3x, right? Yeah. And this one is equal to, this is equal to that, is equal to d e to the 2x cosine 3x, which is equal to e to the 2x cosine 3x plus c2. Yeah, good. So now I have a simultaneous equation that 2i plus 3j is equal to this, right? E to the 2x sine 3x plus c1, and 2j minus 3i, 2j minus 3i is equal to this, e to the 2x cosine 3x plus c2, yeah. So when you solve these two, I get an I, and I is equal to 1 over 13. 1 over 13 e to the 2x 2 sine 3x minus 3 cosine 3x plus c. See? Yes. I can get a J2, right? If you want. Yeah. This is equal to, I have to work out what is the J. Well, and is equal to 1 over 3, 13 e to the 2x 2 sine 3x plus 3 cosine 3x plus c. You see, that can be done easily. This is a really very nice method. Oops. 3 and 2. Okay, I hope you liked this video. Thank you very much.